The topic of this video is what is a consumption function?
And the math behind the economics is mathematical functions.
Okay, in economics we often hear terms like consumption function, production function, supply or demand function. So what does function mean in these contexts? And specifically, what is a consumption function?
So in order to answer these questions, we have to understand the mathematical concept of functions. So what is a function? In general, a function is a rule that assigns to each input exactly one output. So you'll often see a diagram such as this one here, which shows some input going into a black box, a function is applied to it, and the output is some value f of x. So x is the input, f of x is what we say for the output. So a function is a rule, again, that assigns each input exactly one output. So here are my inputs, sometimes known as the domain. You may have heard that before. And when I map them over here by a function f, if this is some value x1, over here I get f of x1. If this is some value x2, when I apply the function f, it comes over here and I have f of x2, and so on. The things that are not allowed to happen are something such as if I have an x1 over here and I have some two values over here, maybe smiley face and sad guy, I cannot have this value of x going to two different places. That is no good. That is not a function. However, I could have two values over here, x1 and x2, and a value here such that these go to the same value. That's okay. I can have two of my inputs go to the same output, but I cannot have one input going to more than one output. That's what this exactly one is talking about. So the functions we're going to be interested in can usually be expressed mathematically. The words we say, as we've been saying all along, is f of x. What do we write? We write it like this. And what do we mean? We mean for each input x, we get a single output, and we call that f of x. In this case, f of x is a function of x. X is the independent variable, f of x is the dependent variable. Here's an example that is given in terms of an equation. Oftentimes you make a t-table, which is the shape of a t, and we choose inputs, say x equals -1, and then we get -1 squared plus 2, which is, let's see, 3. And I could plug in x equals 0, I'd get 0 squared plus 2, which is 2. I can plug in +1, I get 1 squared plus 2, which is 3 again, and so on. So I can make a t-table. This is a numerical representation of my function. I can also have a graphical representation of my function where I plot those points that we have just noted before. If x was -1, we found that y was 3, so that'll be a point on the graph of my function. If x is 0, y was 2, that'll be on my graph. If x was +1, y was 3, and that would be a point on my graph. And then if I wanted to graph the entire function, I would connect those and estimate what the function looked like overall. This function is a parabola, and it looks like this. You can also have functions of more than one variable, a function of one variable, a function of two variables, and each variable is something, an input, that affects the outcome of the function, the output. So here's an example just written in this way. I have two variables, x1 and x2, and the function given algebraically, 3 times x1 plus 4 times x2 plus 6,500. Another example might be how long it takes you to drive to work. How long does it take me to drive to work? Well, that's going to be a function of how far I live from work and how much traffic I have that day. So that's a function of two variables.
Okay, let's use this information to answer the question posed earlier about what is a consumption function. We know empirically that consumption depends mainly on disposable income, so we could write the consumption function as consumption is some numerical function of disposable income. If we know the numerical relationship between consumption and disposable income, we might be able to write the function, for example, as consumption is equal to 200 plus 0.75 times disposable income. If we were to graph this function, we see the consumption line plotted here. If we added another variable to the equation, this would cause and this change, then this would cause the consumption function to shift up or down the way it's graphed here. Okay, other times we use functions, commonly we talk about production functions, where output is a function of the amount of capital and the amount of labor used in the production process. So here are two examples of production functions. The second one is an example of a Cobb-Douglas production function, which is common. Other examples of functions in economics: supply and demand functions, money demand functions, and there are several other examples listed here.
Now we've seen how to use the math behind the economics to understand consumption functions. Thank you so much for listening.